Hi, how are you doing? How's everyone doing? I'm good, thank you. Me too. Hope today's Friday, but it's only Wednesday. Well, it's Friday for this class. Let me get my files open. So if you have joined, check out our assignments for the lab today. And I'll talk about the announcement shortly. So we'll wait a few minutes for everybody to get on Zoom. Uh, Good, thank you, Jason. How are you doing? Making coffee, huh? Trying to stay awake. I feel it. Yeah, it's the end of the day. It's a little down. Hi, everyone. How are you doing? Check out our lab for today. We are doing the last lab. Are you excited? Soon you don't have to get on Zoom on Wednesday. So next week, there's a discussion thread, but I'll be on Zoom. If you have questions, you can pop in. It's not mandatory. There's no more lab after this week. Okay. So we will dedicate time to work on projects, final review, assignments. But if you have questions, you're welcome to stop by Zoom, join Zoom, and then I'll be here on Wednesday. Monday, we'll still have a lecture. Okay, we'll wait one more minute and then 6 o'clock will start. So download your lab, look it over. So today we'll do Caesar Cipher. Okay, so we're still light right now, but I'm gonna go ahead and get started. Welcome back. This is our last lab for CIS7. On Monday next week, there will still be some lecture, and then we still have a quiz, but we will not have lab on Wednesday. So for Wednesday, if you have questions or if you need help on something, you can join Zoom. I'll be here for most of the session. And then if you want to meet outside of regular lab time, then you can see me during office hours. Okay. So today we are doing the last lab, which is we're going to spend time learning Caesar Cipher, which we talked about in our lecture. So before we start, let's look at, sorry, I was posting my video for the other class here. Let me get to CIS7. So for this week, we are wrapping up with our lab, and then I'll post the video for you after class. We will have a lecture on relations, which is unit 12 assignment. There is no lab next week, but you have a discussion thread, so you can use that time to post discussion and work on your homework assignment, which is very similar to what we've done every week in the regular assignment. And then the following week, I will post quiz. So in week 13, I will use our lecture sessions to go over your final review, and I will post that next week as well. So you can start working on that if you have time. If not, you can just join the session. We'll do it together. Okay. So today we are going to work on cryptography in C++, and we are doing linear shift or Caesar shift. And in the lecture, we talked about how we encrypt. We would shift the character down so many spaces, right? And then when we decrypt, we would shift it the other way, which is left, and that's going to give us the decryption, which is in plain text. So now, since we use the English alphabet, we're going to use mod 26, and that's going to be the characters that we need to implement. Then we are going to implement the shift value, which is n, okay? And then each of the character will be your x. So when it encrypts, it's going to take the character, it's going to add the shift to the right, and then we wanted to mod 26. When it decrypts, we would subtract the shift value, which is when we shift left, and then we are going to mod 26. So here it gives you a little bit of illustration on how that's done. Okay, in the first example, let me pull it up. You are doing a Caesar shift, and in this program, it's very straightforward, very simple. We only have one function, and this function uses data type string, and the function name is encrypt. Okay, and in the argument, we are going to use string as the type and text. So we're going to pass string text and int s, and s stands for your shift. So as you know that we have upper and lower case, and when you look at this, I want you to also check out Ascii table. Okay. And we know that in the Ascii table, when we look at the values in decimal equivalents, so for example, capital A is 65 and lowercase a is 97. So they are different in numerical values. So that's how the computer can distinguish between upper and lowercase using ASCII encoding. So then when we look at the program, you have a function called string encrypt or encrypt. It uses string. And we have a variable that's going to store result, and that's going to be the string. So when it encrypts, it's going to store it here. Then we are going to use iteration method. We're going to iterate using the for loop. We're going to start with the first character, and we're going to go to the end of that string, which is the length of that string, and we are going to increment. So we're going to move to the next character in the next loop. Then in the for loop, we implemented the if statement, and we would say if and is upper is a built-in for C++. If the text is uppercase, right? If the character is uppercase, then we are going to subtract, okay? For each of the character, we're going to convert it to a numerical value, okay? And then we're going to subtract 65, and that's how we're going to convert. Why is it 65? Well, if you look at the ASCII table, we mentioned that uppercase A is 65, and that's the first character if we're looking at A through Z in uppercase. So that's why we're subtracting 65 there, okay? So then we are gonna mod 26, okay? So inside here, we're gonna convert it from the character, we're gonna parse it into integers, mod 26, and we are gonna rotate it to the beginning again, so that will be plus 65. So here, this allows you to encrypt uppercase. Now for the lowercase letter, then we would use the else statement. And for the else, this should be tabbed in. For the else, we would have the result, and that will be lowercase a, that's 97. Okay, so the same implementation for the uppercase, we're just changing the value. Why is it 97? Because if you look at the Ascii table, lowercase a is 97. Okay, so then this is going to allow us to encrypt the lowercase letter. Then we're going to return the result, okay, as it would store the encryption. So this particular program only encrypts, and we will do one that will decrypt later. Then in the main, you would initialize your text string. That would be the plain text that you want to encrypt. So here we have attack at once, and we want to encrypt that attack at one string using the function. Now we are going to do a 4-character shift. So I want to make sure that I am matching with you here. Yes. So we are doing a 4-character shift. So your int s represents the shift value down the alphabet. So we are moving it 4 space over, and then whichever letter it lands on for each of the character, that's going to be the encrypted value. Then we're going to have it see out, display text, display the shift, and display the encrypted text. Okay, so when we run this program, it's going to give us the text is attack at once, the shift is 4, and the cipher, the encrypted text is this, EXXEGO, and so on. Okay, so this is a simple program that encrypts characters in string, okay, and it allows us to encrypt upper or lowercase. So what we want is, see, you notice that this is uppercase, it's going to give us uppercase in the result. If you have attack at once in lowercase, then it's going to give you the encrypted text in lowercase. Okay, any question with the program? So for this program, you are going to enter it into your IDE. You are going to run the program, and then you're going to answer the questions. So it asks you how many characters are you shifting in the program, and we see that our shift is going to the value for that is going to be stored in the variable s, and it's the int s here. So s, so you're going to shift 4. Okay. Any question with the program, its output, or the first question A? Okay. So as we shift, we're going to add the S here inside. So when you look at the result, As it loops through for each of the character in each loop, it's going to add the shift value, which is 4. We hard code that in, right? And then the values here just represents that this is the uppercase A, that will be the first letter in the alphabet. And then this is the lowercase a, that's the first lowercase letter in the alphabet. Okay. So after you add this program into IDE, then you answer the questions. So we want to verify that the program output is accurate. So you can use this chart to look at your shift. So the first letter for our plain text is A because we have to solve for attack at once. So A, if we count 4 over, 1, 2, 3, 4, that's going to give us the E. T, here's the T. We count 4 places over, 1, 2, 3, 4. That's going to give us the X. So we have the X. And then T again, we're going to get the X. A again, we're going to get the E. When we get to C, here's C. We count 4 to the right, 1, 2, 3, 4. We're going to get a G. So C, when it's shifted, that's going to be G. And then your K, here's K, 1, 2, 3, 4. That's going to be O. And then we have the A again, that's easy. We already counted that, so that's going to be E, T, and then for your O here, 1, 2, 3, 4, that's going to be an S. Okay. And then for your N, 1, 2, 3, 4, that's going to be your R. And then C again, we already know that C is going to be shifted to G. And then your E, 1, 2, 3, 4, that's going to be I. Okay. So for 1B, all you have to do is check with the manual shift to see if your output is accurate, which matches. Any question with exercise 1AB? Okay, good. All right. Then after you enter the program and run it the first time, we're going to come back to the program and we are going to go down to the main. We are going to modify the shift, and you can play with this a little bit. So let's say that I shifted 13. I do an ROT 13. I can run this. Okay. So it tells me that my text is attack at once. I shifted 13. It is in capital letters, so it should give me uppercase letter as the output. So when I shifted at 13, I get this. Okay. What if we modify it and shift it to 8? And so as you can see, when you change the shift value, you would have different output there. And that's the intention with the shift cipher. Okay, so we originally had 4. So you can edit the value for S, the variable S, which is your shift value, and then you can run it. Okay, so if I do a 12, so what you do with the next question is after you change the shift value, you just go ahead and tell me which value you use. Okay, what is your shift value? What is your plain text string, which is attack at once? And then what is your output? And that will be varied, right? It's different from one student to the next in that it depends on your shift value that your output will be different. So keep in mind that this is a linear function. This is just a regular shift down the alphabet, right? So when you're implementing 2-dimension, like for Visioneer, you have to incorporate the key, and that key, right, the letter for in the key. So if it's a string, let's say that the first letter is A, that's going to be the value that you're going to use to add in as your shift. Okay, so when you implement Visioneer, you would use the key value here. And so that means that you might not want to use int, you might want to use a string, so that way the user can input your key. And then each of the letter for the key is going to line up like what we practice manually, right? So think about how you would implement the solution for that, how it would correlate and shift by row and column cross section. Okay, so for question C, we simply just change our shift value, answer the questions after we run the program. And then for D, I want you to look at the function, right? And explain how that is used for the encryption as the encryption algorithm. So when we go back, look at your function, you can just provide a brief explanation. So here, and we talked about what this is and what this is. And it uses a for loop with a nested if else. So if you want to create a decryption program, instead of adding the shift first, right, we have to subtract it. So we would have to start with an encrypted string. So what you can do is you can add to an existing program like this after it encrypts, right? It can take whatever that was encrypted and then convert it back if the user chooses to do that. Yes. So the way that we use this is because if you're looking at the ASCII table, okay, let's say that I have an A, which is 65. If I add a 4, if you count down 4, 1, 2, 3, 4, that will be the E, and it's 69. So when you do a plus, the plus shift value there, it's just going to go down the alphabet. If you subtract it, it's going to move it left. It's going to move it up. Okay. So you're using arithmetic with the encoding values to be able to implement the shift. So if you look at the program, if we add the S here, so if I have 65 plus 4, that's going to give me 69, which is an E. E is farther down the alphabet because E is encoded with 69. Okay, so when you do a plus S, that's always going to be shifting right. And if we want to subtract it, right, then we're going to shift left. Okay, good. Other questions? Okay, so for D, we explain the the purpose of that function, how it's used to do the encryption. Okay. And then while you have that going, I'm gonna go back to my folder. And if you use REPL for your project, like I said, you can fork it, you can share it, you can program directly into this. And then your CPP file is here, right? If you wanted to add file, you can click add file. Now, when you're done, you can download it. Okay, you can download the whole folder or you can download the zip because it organizes it as a project folder for you. Okay. Okay, so you saw one approach in exercise 1. Now we're going to look at another way to do this, okay, to do the encryption. It's a little bit different than what you've seen with the other one, but in this one, we're using char and shift value, which is the key, okay? So example 2, this one allows the user to enter the plain text, okay? So we are going to treat it like an array of character, and it's going to hold up to 100 characters. And this is an array of character called message. Okay. And we are going to use int I and key and ch. And ch is a char type as well. So we want to display to the user, enter a message to encrypt. Okay. And we are going to use getLine as to receive the input from the user. And as we receive the characters, we're going to put it into message. Okay. Then we are going to ask for the shift value. So in this one, we don't hard code it. We are going to have the user input the shift value. And as they enter a value for the shift, we're going to put it into key. Then, and this program doesn't have its own function, so you built everything into main here. So here you would have a for loop, and you wanted to iterate through, access each of the character that they have entered. Okay. And with that, what we're going to do is each of the character from the message, we are going to store it into CH. And we wanted to check for upper lowercase, right? So that means that we would take CH and we are going to look at whether it's equal or greater than A, lowercase a, and CH is less than and equal to Z, because we want it in that range, which is our alphabet. So first, this one, it's going to deal with lowercase first. So it's saying if the character is, right, A, starting with A or any character in between up to Z, we are going to take the character and we're going to add the key. And then we nest another if. If it is above Z, okay, then we are going to take the character, we're going to subtract C plus A minus 1. Okay, so what we want to do is this if here, we wanted to control it. We wanted to make sure that it is going to handle the encryption here. So if it's above Z, we are going to take CH, subtract Z plus A. So when you look at the Ascii table, here's A, that's 97. Okay. And then further down, your Z is 122. So if the user input in the curly brace, for example, that's 123, it's going to take 123, it's going to subtract 122, because the computer, when it computes it, it's in binary, right? So it converts it to binary, and then the reason why that we do this is when we encode it, so that way we can use it for, this is for human purposes. Okay, so then it's, so if I have something that's above Z, I'm going to take that value, I'm going to subtract it, and then I'm going to plus the A and I'm going to minus the 1. So if I have 123, it's going to subtract 122, which gives me 1. And then it's going to take that 1 and it's going to plus it with the A, okay? And then it's going to subtract 1. So what that does is it's going to then move it into what we would see as a symbol. So when we after we subtract 90, when we have the 97 here, and then we're going to subtract 1, it would then take it to the symbol area. And that's that's how we would handle the symbols. Okay. Now keep in mind that ASCII, right, has limited number of symbols. So, you know, and with your compiler, it's able to convert the equivalents of your character into ASCII, decimal equivalent. So then as we go through, right? So here we would have the nested if. So we wanted to control the lower cases and then the symbol. And then here is your character as it for the index as it index it. And then we have an else if. Here is where we handle the uppercase range. And then we would do the same thing with the nested if under else if with the uppercase. Okay. So then if you have the encrypted message, you would then, because you have the encrypted message as it accesses each of the index, then you wanted to bring that here and you wanted to display it. So when I run this, let's say I would have hello like this. Oh, let's do. Okay, and let's try that. Okay. Then what we're gonna do is it's gonna ask for the shift value. Let's say I put a 4. Okay. So you notice that when it encrypts, my symbol stays the same because we did not implement the shift add, right? We're only going to add the key to the character, but here the symbol stays intact. There's no shift for the symbol. So the symbol stays the same. Okay. Now let's run it again. And let's say if we use all uppercase, and let's say I wanted to use that, a 4. Okay. So again, as you can see, it gives me LIPPS with the slash, just like how I use the slash at the end. Okay. So put number 2 into your IDE. And for this, I wanted you to test what we are Klingons. And I want you to shift 13 first. You can play with it, but for our exercise, let's try that. Did I capitalize that? Yep. Okay. So we are going to test it with we are Klingons, and we're going to shift it 13 places. So when we verified this, let me go copy this so I can do it with you. Okay. So we'll start with the W, and then we'll wrap it around. So here's W, and we're going to count right 13. And when we get here, we're going to come back to the beginning. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13. So the W is going to give us the H. And then the E, it's lowercase. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you have the R. And then for the A, you count right again for 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let me double check. Yep. And so on. Okay. And we wanted to do upper and lowercase appropriately because the way that the program is created, it handles upper and lowercase. So we wanted to verify. Am I off on the first one? 1, 2, 3. Yep, I'm off. Okay. So check it and then verify if it's correct. Then for B,
Professor,
yes.
could you show your output for that one again?
So JRNE capital X Y VATBA.
For some reason, I'm getting a question mark where the S should be. The last.
Yeah, on the last one, that's right. Because and it does show it on mine. It's the BA and then there's a little symbol there. Because what happened is when you get the S, I'm going to show you why. So when you get the S here, it's going to go 1, 2, 3, 4, 5, 6, 7, right? 8, 9, 10, 11, 12, 13. So instead of wrapping it around again, what happened is the flaw in this one. So when you get to the capital S on the Ascii, look at the S. Okay, it's 115. So numerically, if we look at the program, so when it gets to the lowercase s, um, it's supposed to come back and add like, add the key. So that value added with 13, okay? So your S is 115, added with 13 is 128. Guess where ASCII ends? 127. So it reached the ceiling for this. So it's not able to take whatever what that 128 is. And so therefore you're getting that funky little symbol. Okay. Because with the S, when you add 13, it's 128 and 128. What is 128? Well, there's down here, if you look at 128, it's this symbol supposedly. But your compiler, it probably doesn't know what that is, right? Because if it doesn't have the extended ASCII codes package added, it will not know what that is. So it shows that little question marks. Okay. Any question? Now, extended ASCII code, not it doesn't always come equipped. Okay, so you would use this when you're trying to work with like symbols or alphabets that are non-English. Okay, like French and sometimes, in other languages where you would have letter with the accent on top. Then in that case, and that makes sense if you think about like word processor applications, right? The type of font that you choose is going to give you the character set, but Microsoft Word uses like a different encoding compared to ASCII because ASCII is limited. It's only 127 for general, and then anything above that, right? So in the word processor application, you would use encoding system that is higher. It's going to handle more characters than your ASCII. Okay, so the S again is that it's lower in the it's higher in the value, and you can test it with like the later characters too. So with the S, it's 115 plus 13, it's 128. And 128, it's supposed to give you this symbol, but it doesn't know how to interpret it, so it add in that little question mark box. It's a placeholder for something that it cannot interpret. Okay, so we are going to look at the program for B, and I want you to focus on this area and explain, right, how it uses the shift to encrypt for lowercase and uppercase, and how it uses the symbol. And I explained this at the beginning of number 2. It's very easy, this one. So I see a lot of Visioneer program that uses this technique. Okay, the downside of this technique you saw already when we put in We Are Klingons. So when you test the limitation of this program, if you use a later letter, right, like Z or something like that, see how it handles it. Okay. And how would you fix it? Okay. And then for C, I want you to compare example 1 and 2, explain the differences between the programs. So when we look at the first program uses, it parses it into integer, right? And it uses the integer equivalents of upper lowercase a to start, because that's the first letter in the alphabet for that range in uppercase or lowercase. Compared to this program, it's used a character, but the way it approached it in that it's still going to add the key, but it's using the operand here as implemented the range with the if. And so you can explain the difference in the mechanical of the program. Are you shifting 13 or 14? Devin, check your shift key, or there might be something off. Okay. Yeah, so maybe check the line possibly here or here. Okay, so look over your code. Because if we manually check it, if we start with the W, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, it should be a J. And we talked about how ROT13 was used back in. And when you look at different example, people approach this a little bit differently, right? So commonly you would see these type of example uses, you can parse character into integer and then handle it that way, or you can implement it like this in the range of the alphabet A through Z. So for C2, just compare the two programs, explain the differences. Okay, any question with two? So I wanted to use a separate program to show you so you can see the difference, because if we built it into one program, sometimes that can be hard to see. So then in the next one, you're going to see the decryption. Very similar to number 2. The only main difference that we see is that it subtract the key, right? So when it subtracts it, it's going to move it up to the left or up the alphabet. So when we subtract it, then we shift left. Okay, and it did it for both parts. So for 3, if you wanted to edit your number 2 program, you change the plus to minus really is, and then modify some of the output text, the decryption here. Okay, so let's explain it real quick. Same like number 2, you have everything in main. You have a char message that's going to store the user input up to 100 character. We're going to use char ch, which is used here. And then I for indexing in the array of characters from the user input. And then the key is what we're going to use to shift. We're going to prompt the user to have them enter the message to decrypt. We're using getLine to receive the input, C in getLine. Okay. And as they enter, each of the character will go into the array message. Then we are going to prompt the user to enter a shift value. They will enter an integer, and that's going to store into the key. We have a for loop. We're going to start with the first character in that message. And here it says if the index, right, of that array, which is the character in that message, if it's not string no, right, this is going to be what? If it's not a no terminated character, right? So here we wanted to get it to the end of the string, which is the null terminated character. That's what it's saying. It's going to loop all the way to the null terminated character. It's going to move one character to the next by incrementing it from the index, so 0 to 1 and so on. For the character, we are going to access each of the character in the message and put it into CH. And then here we are doing the range for the lowercase if CH is equal or greater than lowercase a and CH is less than or equal to lowercase c. We're going to take the CH, which is the character, and we're going to subtract key. So we're going to shift left for decryption. If CH is greater than A, then CH is going to be plus C minus A plus 1. And this is going to handle the symbol, but it doesn't shift the symbol, it's just going to show you the symbol, just like the other one. Okay. And then in the else if, we would we would implement the range for the uppercase A through Z. And we're going to subtract the key to shift left. And this is going to handle anything that's above uppercase A. We're going to treat it as the same for the symbol. And then for the CH, it's going to store each of the character for the message. Then we are going to output display this decrypted message. And we are going to show the array message, which contained the decrypted character. Okay. So let's try, I'm going to try this real quick. I'm going to take this EX, right? EXEG. So you can take this value and you can see if it's going to decrypt it to at once by shifting 4. GI. me rerun that. See, double check. EXSRGI. Okay, so let me double check if I changed it. 1 second, okay. Yeah, so the example is the same. And then it's going to tell you to do crypto. But what I'm trying to do is I'm trying to decrypt the exercise 1 message. It's the same. It's the same file. Okay. So it's the same exact file. So what I'm doing is when I run it, I'm trying to decrypt the first message to see if it's actually working. Because it should tell me attack at once by shifting 4 left. But in this one, it fails because it can't, there's some issues with the later characters where it's going to show symbol like what we've seen. So it's above its range. Okay. So there's a flaw in this program for the decryption. Because if we could encrypt it with the first program, we should be able to decrypt it with this program. Or you can take the last encryption that you did for We Are Klingons and then put it in here and see if it's going to be able to, and shift 13 and see if it's going to bring it back to We Are Klingons, right? As you can see, I'm not getting the output that I want. Okay. So I try to test it with the exercise 1 output and I'm not getting the attack at once. So this program, it doesn't decrypt correctly. Okay. Because if it did, it should be able to give me attack at once. It's only able to give me like some A's and then the rest is not able to do it. Okay. So now you can see the weakness in that program. Okay, so here I just have you do a crypto. You can take an encrypted message and then you can do the shift to test it. Okay. Yeah, I know. It's the compiler issue. So if you read the text, Jesus mentioned that on Visual Studio, right, it outputs correctly. And that's because you have the appropriate packages. But for your program, when you build your program, right, considering that that program needs to be able to handle on different IDE. Because when you turn in program to me, I test it on this and I also test it with IDE. But in the case where if you run that program, how is it able to adapt to that platform? So that will be something that we would consider. So yes. When I did this in class, they use Visual Studio and some of them use this REPL, but yeah. So I like for you to test it with an encrypted message that you previously had and then see if that works, okay? So for A, let's do that. And then for the functionality, we already talked about how it subtracts the key. So explain the functionality for the decryption. And we want to compare this program to the last program. We're just going to identify the main difference and the similarities between them. So it's almost identical in the fact that one is encryption and the other one is decryption, right? 2 is encryption and 3 is decryption. And 2, we add the key, and 3, we subtract the key. Let me try the lowercase on REPL and see. EXSRGI. We're going to shift 4. Yep. Okay, so explain the functionality, provide the explanation for the difference and similarities. Okay. Any question on 3? They're short little programs, so we're going to do 5 today. All right, let's take a look at number 4. So for example 4, another encryption program. And in this one, we are using string. Okay. We are also going to allow the user to input the message and the shift key. So this is a different approach than what you've seen in the other 2. Okay. So at the top, you prototype your function. So I have a function called encrypt, string type. Okay. So we're going to, for the argument, we're going to use string and int. So here's a prototype in the main. For the main, we're going to use ARGC, and here you notice that we are going to point. Okay, we're using pointer. Now, and the pointer is used in the argument. So then we declare string source, so source, and it's the type string. Key, that's going to be our shift key. So we're going to prompt the user to enter the message. As they enter it, we are going to store that into source. And we're going to ask them to enter the shift key. The number that they enter for the key, that's going to store into key variable. Here is the display of the encrypted message. Then we're going to call on the encrypt, which is our function, and we're going to pass source and key. So in the function definition, as we're using source and key for that function, that's going to be in your argument. And the string encrypted, okay, here we declared it as source. And we're going to use a for loop to iterate through each of the character up to the end of the source, which stores the input from the user, plain text. Okay, so it's going to iterate through each of the character of the plain text up until the end, the entire length of that string. And it's going to update it's going to go from one character to the next by doing the increment. Then for the crypted, we are using the array here. And that all that is instead of I, we're just using current. That would just be accessing the index. Each of the character, right, in source is then going to get added with the key. Okay, whatever the key value that we enter. So if we enter 13, then it's going to get added. Okay, so let's do this. So you're going to go ahead and enter that program into your IDE. And we're going to try it with substitution shifting 5. I tested with We Are Klingons and see how that will work, but now we can also check with uppercase. Substitution. Can't type today, huh? Okay. So if I enter the uppercase, it gives me uppercase. If I enter the lowercase, it gives me the lowercase. Let's try it with the symbol. Okay, works with the symbol. So here it handles both, right? Okay, so after you have your program running, you're going to test it with substitution, shifting 5 places. What are you getting for the output? And so you can play with it to see if it has any problem. You can try it with the symbol, lowercase, uppercase. Then for B, we wanted to look at your program and then see how the shift is integrated. So as we look at this program, we know that the function encrypt, that's going to allow us to shift, right? And so here we use a for loop. And for each of the character, we would then add the key. And then we just call on that function when we display, which is in main. And this one's a little bit different in that in the main, right? You're using char, your argument here, that's going to be pointing to the array, which is going to be indices, accessing the index with the for loop, store it into encrypted and return. So look at the function and explain the shift implementation in that program. And I want you to evaluate this program compared to the first and the second program, which are both encryption program using shift. What are some of the similarities and differences? And in your opinion, right, which one's efficient or accurate? So as far as complexity, I think that really pretty close, but in this one, the only main difference is that you're using this and you don't have to implement a lot of like the nested if else compared to the others, right? Any question? So do your best in the comparison. Any question on 4? And while some of you are finishing that up, let me open my 5th program. Let me double check. See, I think you also have the same. Okay, so you like the number 4 more? I do too. I think that you can achieve the same thing. It's just how you approach to solve that problem. So you see variation, right? Um, I think the first couple program for the beginning students that might be easier to understand, like the first one, the second one. But the later ones you would see. So it's just understanding like ASCII conversion and so on. But let me see. I might have it misfiled somewhere. Not able to find it. Oh well, I'm just gonna have to explain it on here. I have to look for. I'm probably moved it to a different folder if I use it for another class. Okay, so for example 5, this one is a little different than the others. There's some similarity with this one compared to the first couple. Okay, so this one you have. Okay, so you have char Caesar and it's going to pass char. So this is going to be for your function is going to be Caesar on line 6. Then in the main, you're going to have string input. Okay, and you have a do while. So it's always going to prompt the user, enter ciphertext, press enter to continue. And then it's also going to do enter a blank line to quit. Similar to the others, it's going to use getLine and it's going to store the characters that the user input, and it's going to show what they entered. Then inside the do, you have a for loop, and it's going to use the for loop to access each of the character index up to the end of that message or the input from the user. And it's going to go from 1 to the next character by incrementing. Then it's going to take the user input, each of the character, and it's going to, here is where we call Caesar, which is a function, and we pass input indices, okay? Then we're going to add it to the output. So output is equal to output plus Caesar input. So then in the while, it's just going to say while input length is not 0, right? We wanted to make sure that they enter something. Okay, so that's for the while. Now in the function Caesar, we wanted to check if it is alpha, then it's going to force it to convert it to uppercase. Why do they do that, right? Because the parameter that they're using is going to be limited to the uppercase plus, you saw some of the other ones where when you have the lowercase letter, when it gets to the end, you have to be able to handle when it reaches the end of the ASCII range. So it's going to convert everything that the user typed to uppercase. Okay. And then this is where it's going to do a 13 shift. So it's going to shift to 13. And then we are still going to use the mod 26. So we're going to subtract 65 because 65 is the uppercase A, and then we're going to have to plus 65 at the end. So it's like the number one exercise, right? But in this one, you would add the shift value into here, and then you force it into having all uppercase by using 2 upper. Okay. And then we're going to return C. So each of the character is going to make it into uppercase. It's going to shift 13 and then return, and that's the function. And then that function is then passed in, and it's used in the for loop. Okay. And for each of the input, it's going to take that and then use that input in the function, return the character, and then so on. Okay. So there's some layering in this program in that you have a for loop here, you have the function here. The function is used in the for loop. The for loop is, the do is only going to be used to prompt the user. And then the while is just to check to make sure that it's not empty. Okay, it has some kind of characters. Okay, and that's the program. So as you look at the program, you can enter that into your IDE. And then look at the program. You can identify the shift value, which we see here, right? And I want you to check to see if it handles characters. So try entering something with character, symbols. So special characters or symbols, does that work? And then use characters string here. So input characters into your program and check what is the output. Is that accurate? That's correct, Rashad. So Rashad mentioned that this if is alpha, right? So if you use, so is alpha checking for alphabetic characters? That means that it eliminates digits like numbers. Okay. So there's some validation in the input there, right? Some, not that great, but at least the minimum. Yeah, I do have some Visioneer turn-in similar to this one, where it forces everything to uppercase and then it checks for alphabet. So some of the students, they use this one for their Visioneer program. And that's okay too, but test the program and see, how the approach of the program, is that feasible? Is there a limitation? And, if you want to use it, how would you fix it? How would you extend it? Okay. Okay. So then after you test it with characters, look at the section of the code and explain to me how Caesar shift is integrated. So look at your function and then how that function is used in the for loop here. Okay, like right here. So give me a few sentences on that. And compare program 5 to program 4. What are the similarities and the differences in the shift for ciphering? Which one do you think is better, more efficient? Which one's more complex, performance wise, accuracy wise? So with the exercises that you see today, you're presented with variations of solutions for Caesar Cipher and C++. Okay, we did the decryption one so that way you know how to shift left, but for the majority, we looked at some encryption approach for shifting right. Okay. So for 5, you would end with the comparison. And I didn't put any screenshot. If you wanted to add screenshot, you can. Okay, I know that we've been doing it since the beginning, so habitually you already do some of that. I didn't include any requirement on this one. So some student asked last semester, yeah, you can include screenshot. Really, like I said, these assignments are for you. They're really designed for you so that way you can reference it later if you need to, or go back so you can use it as notes. And that's how I design a lot of my assignments, is for the student to go back and review, and not just for this class, but what if down the line you're trying to go back and look at how you went through some of these exercises to solve something, then you have something to reference. Okay, so yes, you can include screenshot, but if you didn't do that throughout, that's okay. Okay. So when you finish, you can save everything, provide your answers, and if you have screenshot, you can include them. You can include them as separate files, or if you put it all in one document, that will be great. And then you can upload it onto Canvas. And you don't have to finish everything this evening. You have a couple of days on this. Okay. Any question with question 5? I have to look for my program. I think I moved it to one of my other C++ class. Okay. So one thing I forgot to mention at the beginning, I posted an announcement today. I kept forgetting to do it, but UCR had reached out to me for data science. I know some of you are interested in this. So here's the announcement. It says woman in data science, but you can attend if you're not a female student. All genders are invited. The presenters are UCR, PhD candidate, master's students, and lecturer. or faculty. So you can sign up for different workshop. I'm planning to attend a couple of them. So it's on Saturday and it's from 10 to 4:10. They do this as part of their initiative to expand their data science program. And also, we partner up with UCR on a grant for data science. So once it's approved, it's actually articulated to transfer for the majority of the classes. So there will be an associate degree of science and data science at RCC, MVC, and maybe Norco. Norco hasn't given us a definite answer right now. But so some of the, and then those courses also will be articulated for UC Berkeley and UCSD transfer. I'm working on UC San Diego. Um, I have some of their stuff here as I look at some of their course description. But it's a hot field right now. I'm sure you probably heard about it, right? From machine learning, big data, data analytics. It has statistic in programming components. And for a lot of the schools, it's under computer science subdiscipline. But some other schools, they would put it under statistic, okay, which is a different department. But so if you wanted to check out UCR stuff, workshop, learn something, I think there's presentation on R and Python, okay? Like data visualization with Python, you know, using R for analysis, stuff like that. So check that out if you're interested. All right. Okay. Any questions before we end? That's it for my lab today. Thank you for attending. This is our last lab. So fast, right? Next week we have discussion and lecture, and that's it. So we don't, you're not required to attend Zoom on Wednesday, but I'll be here on Zoom. Type your name into the chat. Have a wonderful evening. I will stick around for questions if you have them.